Hi everyone, welcome to Vedantu NEET English. I am Diksha Ma'am, your chemistry master teacher. Everybody, let us see if I am visible and audible to all of you or not. Yes, the live has started. Tamil, yes, the live has started. Very good evening, students. So, in today's lecture, we are going to do part 2, that is our zero order reaction, first order reaction, second order reaction, and nth order reaction. And this is actually one of the most important lectures, right? Reason being because from here around, from this particular lecture itself, you can expect around 2 questions for sure in your NEET exam, right? So everybody, shall I start it? If I am visible and audible to all of you, let me know. And let me also see that how many of you have done your homework, right? So, Abhiram has done the homework. Lalhiru has done the homework. Jayasri has done the homework. So these are the 3 students who have done their homework, right? So that is great, right? And what about other students? Why you have not done your homework? Yes, everybody, why you have not done your homework? And also, I am waiting for you because I have already prepared a DPP for you, right? Let me just show you here in the description box, right? This is session PDF link. This is nothing but the DPP only. You can click here and you will get to this link, this portal here, right? So this is your DPP, right, of solution chapter, right, along with the questions and along with the answers. It is there along with the question and answers. We have 25 questions here, right? So as I promised you that I'll give you DPP, so this is your DPP of solution chapter. Now your task is to solve it, right, before let's say I give you 3-4 days to solve this DPP of 25 questions, right? Now, after the completion of chemical kinetics also, I'll give you a DPP of chemical kinetics, right? Okay. Yes, everybody. Adina, you have did it. If you do your homework, you have to write it in the comment section so that I also know that you have done the homework, right? Okay. Very good. Ramya, Adina, those who do their homework, please write it down in the comment section. Otherwise, how will I know that you have done the homework or not? Right? Now, this is your DPP. This is what you have to do for the next 3-4 days, right? Apart from the homework, I am saying. Now, let us see what was the homework, right, of chemical kinetics chapter. First question was, for a chemical reaction, there was some chemical reaction given to you. They are saying that for this, you have to maintain a relation between H2, N2 or NH3. So just write the rate of the reaction here. Rate of the reaction in terms of H2 will be dN2 by dt. This is minus because it is reactant. H2 will be minus 1 by 3 dN2. This is dH2 by dt is equals to product side. It is positive 1 by 2 dNH3 by dt. And if you solve this here, you will get to know H2 and NH3, it's not possible. H2 and NH3, this is 1 by 3, this is 1 by 2, but this is positive, so this is also wrong. This is N2 and this is NH3 and this is also wrong. If you see the last one, minus of dN2 by dt is equals to plus half of dNH3 by dt. That is the correct option out of this. So first is D is your correct answer in the first homework question, right? Second one, students, second is, which of the following can be an order of a reaction? See, order of the reaction will be positive, negative, fraction, zero, it can be anything, right? But if you see 5 factorial will be such a high number, and under root of negative will turn out to be iota, which is a complex number. I told you order can be positive, negative, fraction, zero, but I didn't tell you that it can be, I didn't tell you that it can be iota, not possible, right? So that means this is the only possibility of order of reaction, that is 4 by 2, that is 2, right? So here answer is B, A. Next is molecularity of a reaction is equal to order of reaction in equal to. So as I told you in the last lecture, in the elementary reaction, molecularity and order of the reaction are equal, right? This is what we have learned. Yes, 390. Yes, very good, very good, very good. Ramya, awesome, awesome. So, now, shall we start with the order of the reaction? So, I told you that rate is nothing. If we talk about rate law expression, we talked about rate law expression, that rate law expression is nothing but R is equals to K, A raised to power something, B raised to power something, you can say reactant raised to power something, that will be your order, right? Now this order can be 0, 1, 2. So based on that, we will discuss these reactions, okay? So first is, we are going to talk about zero order reaction, okay? So in a zero order reaction, what exactly happens? The value of n is equals to 0. So if you see the rate law expression here, right? Can I write the rate law expression as R is equals to K? If I take the reaction as A give rise to B, okay, so I'll just take it this way. This is A give rise to B, right? Initial concentration of A is A naught. Initial concentration of B is 0, right? A naught, we are taking out X amount here. X amount is the amount that is used up as reactants, right? And here some amount is formed, that is, let's say B naught, right? Or you can say not B naught, let's say it is BT. And this A naught minus X is nothing but this is AT. Now, this is at time is equals to 0. This is at time is equals to T. At time is equals to 0, there is only reactants, there is no product. At time T, some amount got reacted and the final concentration of reactant, this is, you can say this here, you can write this here, AT is final concentration of A, that is your reactant. X is amount of reactant consumed. Amount of reactant consumed. And AT is the amount of reactant that is left behind. Reactant that is left behind. Right? That is clear. The terms are clear. And A naught is the initial concentration. A naught is the initial concentration. Right? Okay. Now, if I want to write it, the rate law expression, I will write it as R is equals to K. A is the reactant raised to power 0 because it is a zero order reaction. And anything raised to power 0 is 1. So we can say R is equals to K. This is our first equation here. Right? This is our first equation here. So I taught you two laws in the previous class. One is rate law expression, and what is the other law? Everybody, what was the other law? That is your differential law. If you remember, dr by dt, right? I told you, like, full concept, throughout we talked about differential law, right? Change in concentration by time. Do you remember that, everybody? Do you remember that? Now we are going to write it in that way, right? So rate is equals to, in terms of reactant, it should be negative. So it will be minus of d of A by dt. Okay. So I can write it as d of A by dt. Now this is the second equation. Now can I equate? This is also rate, this is also rate. This is from rate law expression, this is from differential rate. Right? You can also write it here. This is from rate law and this is from differential rate. Differential rate. Okay. Two definitions, we have used both of them. Now we will equate it. It will be K equals to minus dA by dt. Right? Now, next is nothing but your mathematics that is involved here. So I'll go very slowly because you guys are NEET aspirants and I don't expect that you know integration and all. Right? So I'll go quite slowly here. Right? Now, one term of dA should be here, one term should be here. Right? So I'll write it as k into dt. This is minus of dA, right? Now, whenever you have differentiation, you do the integration of that. So here will be integrated, here this term will be integrated. Integration is from initial to final value. Here initial value of time is 0, here final value of time is t. Initial value of concentration of A is A naught, final value is AT. So we will write it as A naught and this is AT. Now when I am going to solve it, how I am going to solve it? Now always and always this will be constant and constant will be taken out of integration. You will take it out of integration. This will be 0. This is 1 into dt. This is minus of integration 1 into dA. Right? This is A naught AT. This is 0 to t. Okay, now you're going to solve it. Integration of a constant, if I take constant, that means integration of 1 with respect to some variable is that variable only. So integration of this thing is time, integration of this thing is A. So it will be k into time 0 to t and this is minus of A naught to AT, right? This is the formula that I'll also write it here. Integration of anything is this. If I am integrating it with respect to dx, so answer will be x. If I am integrating it with respect to dy, answer will be y. Okay? Yes, everyone, that is the rule of integration, right? That is not important for you to learn the derivation, right? I'm just telling you so that this will be used in your, like, when you are doing the reactions, that will be used. So you should know this also. For the complex reactions, if you want to complex questions, if you want to solve, you should also know how it is derived. You don't have to remember this, but you should know how it is derived. Okay, so this will be k into t minus 0 and this is minus of AT minus A naught and answer will be, this is KT and this will be A naught minus AT and this is your final formula that you have to learn. This is your final formula that you have to learn. Okay guys, understood? Now tell me one thing. AT is equals to A naught minus x. So can I say that A naught minus AT is equals to x? Initial minus final concentration is equals to x. Can I write it there? Right? So that means this I can also write it as, KT equals to x, where x is the amount that is consumed. This is the second expression that is important for you to learn. See, if I give you directly, this is the expression, you will be like, ma'am, this is tough. But now you know that what is the journey behind it. Even if you're not able to recall this in the exam, you can derive it yourself. Worst case. Otherwise, you should know. But worst case, if you're not able to recall this, then you know that this is the formula. KT is equals to A naught minus AT. KT is equals to X. Right, everybody? Clear? Now, let's solve that. What exactly is T half? Ma'am, what do you mean by T half? Right? So, half-life is nothing but when half of the reactant is consumed. Right? Initially, if you have 100, then 100 out of 100, half of the reaction will be consumed. That means you will be left with 50. That is T half. When 50% of the reactant is consumed. That means X will be equals to how much amount? A naught by 2. And AT will also be equals to A naught by 2. What do you mean by that, ma'am? That means how much amount is consumed? 50%, half of the initial value. How much amount you are left with? Half of the initial value, right? So that's why you have this thing here, right? Now, you want to cram it as it is, you can. You want to know that how it is derived, that will also be great. I think you should know how to derive this, okay? So, here, it will be, if you put it in this here, T half, K into T half, because I am putting the value, we know that KT is equals to A naught minus AT. So T is here T half, A naught is same and 80 is nothing but A naught by 2. Right? So can I say this will become A naught by 2? Right? This is KT half. Okay, that means T half is equals to A naught by 2K, and that is your another important formula that you should know for your numerical. So three important formulas we have discussed. KT is equals to, this is the first important formula, right? This is the first important formula, that is KT is equals to A naught minus AT, then KT is equals to X, right? That is the same thing only. Then T half is equals to A naught by 2K, that is the value T half for zero order reaction. Is that clear to everybody or not? Till here, is that clear, students? Right? Because after this, we are going to use these equations to understand the graph here. Right? Okay? So now we are going to move towards the graphs. Students, if there is any problem, you can let me know in the chat box. Right? If that is clear, you can also let me know in the chat box, because when you interact, only then I'll get to know that if that is clear to you or not. Otherwise, your mission will not be successful. Why? Because you need a teacher who can also answer your doubts. If I don't ask your doubts, how will I answer your doubts? And if you stop responding to when I ask you, is that clear? Then I will also stop asking, is that clear? Right? Then you will miss that. Right? So when I ask you, respond to me. Okay? Yes. Now let us see this equation one by one. So now let's see this. Okay? So what I'm going to do is, you can just erase this also. Right? Right? Now one by one, I'm going to make a relation between these things. Right? So if you see R and T, we know that, students, R is equals to K, and this is A naught 0. That means the R is equals to K. Right? We also know that KT is equals to A naught minus AT. Right? If you put here R, this will be RT is equals to A naught minus AT. So now, can you see one thing? R and T are dependent on one thing, that is the change, right? They are not dependent. It's not like in zero order reaction, if the time will increase, right? As the time, we are saying that the time will increase, what will happen? Rate of reaction will remain constant here. So that means rate of reaction, yes. Time will not define the rate of reaction in zero order reaction, right? Your time is not going to define that rate of reaction. If the time is more, rate of reaction will suddenly increase. No. With respect to time, there is no relation of rate of reaction, right? Rate of reaction has no relation with time, right? If the time is increasing, rate of reaction will not change. It will remain the same, right? So that's why when you draw a graph between time and rate of reaction, it will come out to be a constant quantity, right? Now, next is, if you draw a graph between rate of reaction and concentration, see, we know that R is equals to K, A naught this, right? That means 1 only. So we know that rate is also not dependent on the concentration, right? So when you increase the concentration, it doesn't mean that rate will increase. Rate is dependent on the rate constant. So with rate constant, it will change, not with time or concentration. That's why both of them are like parallel to x-axis, right? Okay. Ma'am, purchase the badge, but I cannot shop. That's so sweet. That's so sweet, Lachman. That's so sweet, right? Okay. So next is this one, where you have to draw a graph between A naught minus AT and T. So if you see this here, I'll just draw this here. If you see this here, we have this particular equation, that is KT is equals to A naught minus AT. This is our zero order reaction. Now this is my y-axis, so I'll compare this with y. This is x and t. If this is my x, this is x, not my x, means it's the time, right? So this is x, right? And this is slope, right? And this is plus c. Now, can you see when you compare this with y is equals to mx plus c, right? Y is nothing but a naught minus at. X is nothing but it is time. Slope, that is m, is defining positive. That's why it is positive and inclined, right? And when you talk about intercept, that is coming out to 0. That's why it is starting from the origin, right? So that's why you have this kind of graph here. Similarly, if you talk about, ma'am, I want to draw a graph between AT and the time, right? So if you want to draw a graph between AT and time, you have to take AT as y-axis, time as x-axis, right? So the equation is A naught minus AT is equals to KT. So you can also take it as, I want to take AT as the y-axis, so I'll take it as this is, you can also write it as AT. This is equals to, if you put it here, A naught minus KT. So you can also put it as minus KT plus A naught. So you can also rearrange it like this. That is AT is equals to minus KT plus A naught. You can also rearrange it like this. The same equation I am rearranging here. Same equation. I just put AT over here. If you take AT here, minus KT here, so it will become AT is equals to minus KT plus A naught. Now you have to compare this. This is y is equals to mx plus c. Now can you see the intercept is coming out to be A naught. So that's why here it is A naught, right? And the slope is negative. Because the slope is negative, that's why it is declining here, right? It is declining because the slope is negative of k. Right, everyone? Okay. Now, let's see the next thing, that is x is equals to, now the next is x and t. What was x? X was the amount that is consumed. So again, we'll go to the same reaction. We know that KT is equals to x. So if I compare this with y is equals to mx plus c, if I take this as y, this as y is equals to, this is mx and this is plus c, then I can see that when I compare this, y is equals to mx plus c, wait a minute, x is time, right? And this is the m. This x is x-axis. This x is amount that is left. This is from the equation that we have. This is from the straight line graph, that is y is equals to mx plus c. Right? Now, if you see this here, intercept is coming out to be 0. Right? Slope is positive here. Can you see if x is t? Right? You are comparing it with this. X is nothing but t. The amount that is left is slope. So slope is coming out to be plus of k. And y-axis is nothing but that is x. That is the amount that is. Understood now? This x is different. This x is different. This x is amount that is left. Right? And this x is the x-axis. Right? Okay. So here that's why the slope is coming out to be positive. Intercept is 0. That's why it is starting from the origin. Everyone clear? If that is clear, then you can let me know in the chat box if that is clear to you. Next we have is alpha. What is alpha? Now who will tell me what is alpha? Alpha is degree of dissociation, right? Now you have to draw a graph of degree of dissociation. For that, let me know in the chat box what is exactly the value of alpha. Right? What is the formula of alpha? Alpha is nothing but it is number of moles dissociated. Now, how much amount is dissociated? How much amount is consumed? That is x. Divided by initial. So that means alpha is nothing but it is equals to x by A naught. The amount that is dissociated divided by the initial moles. If you see this here, the amount that is dissociated, is x. Initial moles are A naught. So that's why here also you can write alpha is equals to x by A naught. Right? That is the value of alpha here. Right? Now they are asking you the graph of alpha and A naught here. To how you are going to draw the graph. Okay, let's see this. We have this equation that is A naught minus AT is equals to KT. We know that this A naught minus AT, we have to convert it into which thing? That is alpha. Alpha is nothing but x by A naught, right? So if I do one thing, let's say, can I put it as x? Yes, ma'am. We also know x is equals to kt. Now, if I divide this by A naught, then this will become nothing but alpha. This will be alpha. So, alpha is equals to kt by A naught, right? Now, when I compare this with, this is my y, this is y, and this time is x. So, when I compare this with y is equals to mx plus c, when I compare this equation, then slope is k by A naught. Then slope is coming out to be positive of k by A naught. Intercept is coming out to be 0. That means slope is positive. That's why it is inclining upwards. And because intercept is 0, that's why it is starting from origin. Okay, everybody? Is that clear to everybody or not? Right? What we are discussing here is the graph of zero order reaction. Let me know in the chat box if that is clear to everybody. Yes. If that is clear to everybody, you can let me know in the chat box. Guys, see, the name of the channel is Vedantu NEET English. So that's why I'm teaching in English. Right? Okay? Yes. Everyone, where's the energy? Where's the Josh? Such an important lecture, but the energy is so low. Why? Only in the first lecture, you are like fully, like I can crack NEET, I'll do this and that. Then your energy drops. Then you question yourself that why ma'am NEET is not getting cracked. Hey, you have to do hard work, right? You want to do operations by doing nothing. This will not happen. You have to put in efforts also. You have to be consistent. If there are 10 lectures of some chapter, you have to go and watch 10 lectures. Like you binge watch some Netflix series, same way you have to watch the lectures also. You are not like, ma'am, in the first episode, I was so excited. In the second episode, ma'am, I was not excited. In the second episode, you wait for the second episode. In the same way, you have to wait for lectures also. Right? Okay? Yes. So, now let's do one question based on zero order reaction, that is, the decomposition of NH3 on platinum surface is zero order reaction. So, basically they are saying NH3, N2 plus H2. First you have to balance this reaction. This will be 2, this will be 3. Right? What are the rates of production of N2 and H2 if K is this? So, they are asking you rates of production of N2 and H2 if K is this. Okay. See, simple thing is, we know that rate is equals to K here. Right? Rate is equals to K. So, overall rate of reaction you can write. This is a very interesting one. See, we know that R is equals to K. Because K is given to be this, so we can say R is equals to 2.5 into 10 raised to power minus 4. Now, if you see rate of, they are saying what is the rate of production of N2? That means rate of production of N2 specifically, that is, because N2 is on the product side, it will be positive, dN2 by dt, right? Which is, if you compare with rate of reaction altogether, rate of reaction is R is equals to, reactant side is minus 1 by 2 dNH3 by dt. This is equals to positive of dN2 by dt. This is positive of 1 by 3 dH2 by dt. This is what we have learned in rate of reaction in the previous lecture. How to calculate rate. Now see, rate of N2 is nothing but this thing is rate of N2. That is nothing but that is getting equal to R only, right? That means it will be 2.5 into 10 raised to power minus 4 only. If you talk about, ma'am, what is the rate of H2? Rate of appearance of H2. Rate of appearance of H2 is nothing but it is this thing. That is without the division of stoichiometry, that is your rate. Okay. This is the rate of appearance of H2. This will be 3 multiplied by rate of reaction. That means answer will be 3R. So it will be 3 into 2.5 into 10 raised to power minus 4. That is going to be the rate of appearance of H2 and rate of appearance of N2. Right? Okay, students? Definitely, Ramya, it's totally fine, right? Take care of your health, right? And do watch the session on the recorded version because it's a very, very important session, right? Okay, students? Yes, Karthik, Mano, rate of production is 3.75. Very good, right? So, guys, rate of reaction, if they ask you, this is this. They're asking you rate of production of N2 separately, rate of production of H2 separately, and this is how you will calculate the rate of production of N2 and H2, right? Okay. Now, let's do one more question based on this. That is your J question, okay? Now, let us see this half-life of zero order reaction, right? E give rise to product is 1 hour, right? See, JE questions can be as it is repeated in NEET, right? Half-life of zero order reaction, half-life of zero order reaction is given to be 1 hour, right? Then they are saying when the initial concentration of reactant is 2, initial concentration of the reactant is 2 mole per liter, right? Time required to decrease the concentration of this to this. See, firstly, you have to tell me one thing. Can you calculate K is equals to A naught by 2 into T half? You have initial concentration that is 2. This is 2. This is 1. Can you calculate the value of K here? That is going to be 1. You can calculate the value of rate constant, right? Now, once you calculate the value of rate constant, we know that A naught minus AT is equals to K into T. Now, K we have calculated, that is going to be 1. And they are asking time required, time they are asking here, right? To decrease concentration from this to this. That means final concentration from this to this. This is initial concentration, this is final concentration. So initial concentration is 0.5, final concentration is 0.25, that is nothing but 0.25. So time will be equals to 0.25 here, right? But they are asking you, they have given you in hours and minutes, right? And if you see this, we have calculated this in hour. If this is in hour, then this will be also in per hour, right? If this is in per hour, this time will be in hour, okay? So this also will be in hour. So this will be time is equals to 0.25 hour. 0.25 hour, if you please this will be nothing but 25 by 100 hour. That is nothing but 1 by 4, right? If you convert it into minutes, this will be multiplied by 60. That is nothing but 15, right? That is nothing but 15. So answer will be 15 minutes is the correct answer. So B is going to be the correct answer here. Right, everybody? It is there on YouTube. Yes, it is there on YouTube. Don't worry. I just checked it out. Right? It will be there. Okay, guys. So answer will be your 15 minutes is the correct answer here. By this, we have completed zero order reaction. Now, let's talk about first order reaction. Okay, let's talk about first order reaction, everybody. Let me know in the chat box if zero order reaction is clear to all of you or not, right? Okay, then we are going to start with the first order reaction here, right? So what is first order reaction? Simple, same thing we are going to do here, and zero and first order reaction are the most important reactions. Okay, so same thing, we'll say this is, let's say, A to B, right? A naught is the initial concentration. Here product is 0, right? At time is equals to 0, at time is equals to T. This is become A naught minus X. This will become AT. That is nothing but A naught minus X. Or you can say X amount will be taken, that will become nothing but AT, right? And here it will become B naught, that we don't have to do anything with, right? Now, when you apply rate law equation here, you can say that R is equals to K A raised to power 1 because it's a first order reaction. So N will be equals to 1. That is your first equation that you know from rate law expression, right? Now, I am going to do the same thing. I am going to calculate the rate, not from rate law, but also from differential law. That is, in terms of reactants, it is going to be, if I write it here, R is equals to minus of dA by dt, right? That is also going to be the rate law for decrease in concentration of reactant by dt. That is also going to be the rate law. So this is the second equation. So now you have to equate 1 and 2 here. This will become minus of dA by dt is equals to K into A, right? Now you have to take A on both the sides. So it will be nothing but, if you take A on both the sides, it will be minus of 1 by A, this is dA, is equals to K into dt. You can also take minus over here, right? And if you take constant outside the integration, if you start integrating it, you take constant outside the integration and you put the initial and final value of integration, and the limits will be, this will be A naught to AT, this will be 0 to T, right? Okay. Now, ma'am, what is the value of 1 by x log 1 by x dx? So remember this, the value of, I am just writing separately here, right? The value of 1 by x dx integration is ln of x. That means natural log of x. So here the value of this is going to be ln of A. And the integration value is, limits are A naught to AT, and here the limit is minus K. This will be T and this will be 0 to T. Okay. Now, just solve this. This will be ln of AT minus ln of A naught is equals to minus of KT. This is the first equation, and we are going to draw multiple equations here. This is just the first equation that we have solved. This is the first equation that we have solved. You can mark it as number 1. Okay. For first order reaction, you have to remember a lot of equations. This is the first equation. Now, can I also, if I start writing it here, I'll just write it here also. If I write it here, this will be nothing but ln of AT minus ln of A naught is equals to minus of KT. You can also write it as ln of A naught minus ln of AT is equals to KT. So this can also be, we know that, see, from where, if you have studied log and anti-log, I have completed this lecture, I think 15-20 days back, right? So why I taught you? Because that will be throughout your physical chemistry, right? So we know that ln of m minus ln of n is equals to ln of m by n. That is the equation, right? So you can also write it as, this will be ln of A naught by AT is equals to KT. This is the second equation of first order reaction that you have to remember in terms of natural log. Now I'll convert this equation into, or you can say this equation into log base 10 and this equation into log base 10. So let's see what we are going to do there. So if I convert this into equation of log base 10, so this will be log, this will be multiplied by 2.303 log of 80 minus 2.303 log of 80. So I'll take 2.303 as common. This will become log of 80 minus log of A naught is equals to minus of KT. So you can also write it the same way. You can also write it as, if you have this thing, you can also write it. You can take it here and you can divide it here. 2.303. This equation also you can remember, or you can also convert this equation into log base 10. That will be log of A naught minus log of 80 is equals to KT by 2.303. Right? You can also convert this equation here into log. Log of A naught by 80 is equals to KT by 2.303, and this is one of the most famous equations, right, of your first order reaction. So all these equations are equally important for you, right? Okay, in terms of, see, from one equation I have formed all these equations, right? From this equation we have formed all these equations. Let me know if you can do it yourself as well, students. Let me know if you can yourself do this as well or not. Right, everybody? If you can yourself do it as well, you are confident enough that yes, ma'am, we'll be able to do this, ma'am, this is simple, then let me know in the chat box, because after that, we are also going to solve graphs, we are also going to solve numericals, so many things are there. Right? But for that, I also need to know if this is okay with you or not. If that is not fine, this is my marker. I am placing it here. When I see this is okay with you, only then I can teach. Right? If you are too lazy to type yes or no, then I am too lazy to write all these things for you. What I'll do, I'll take printed notes and I'll teach you there. Right? That will be great. Okay? I'm waiting for your answers, and I'll wait if you have enough energy to write yes or no when your ma'am is standing here without any break. From 2 p.m. I am teaching, right? Without breaks. And you guys, you can't even type yes or no. Very sad. Leena is super excited. Others are, I think, sleeping or what in the class. No idea on that. So now let's see the next one. So guys, that is done. Now we are going to see what is half-life period here, right? So if you talk about the half-life period here, no, then half-life period, how you are going to discuss? See, we know that log of A, you can say 80 by A naught, right? You can say A naught by 80 is equals to KT by 2.303. Just remember one formula. If you take for half-life period, for T half, this will become log of, we know that for T half, 80 will become A naught by 2, right? So I can write it as log of A naught divided by A naught divided by 2 is this, right? This will become K into T half. This is 2.303, right? So K will be equals to, or you can say T half will be equals to 2.303 into log of 2 divided by K. That is nothing but, log 2 is nothing but, that is, what is log 2? 0.301, right? That is the value. This is K. And you can directly remember this is 0.396. 393, I think it is. Yes. 0.693, yes, 693. 0.693 divided by K, that is your final formula of T half. That you have to remember. T half is equals to 0.693 divided by K. That is the formula of T half for first order reaction. Okay, this is the formula for first order reaction. Right? Now, let us see the graphs based on this. Same way, guys, we are going to compare this with y is equals to mx plus c, same thing, right? So let's see how. So first is they are saying that with respect to concentration, how the rate is changing. So if you compare this, R is equals to K into A. So we can say it is directly proportional. If you compare this with y is equals to mx, so this is y, this is equals to mx. Can you see slope here is positive of k? So that means, and intercept here is 0. So that means that's why it is starting from origin and it is upwards. Inclination is upwards because slope is positive here, right? Second is, if you talk about this thing here, again, this is y and this is x. So let's compare this. Log of A naught by AT is equals to KT by 2.303. So you can say K by 2.303 T. Same formula. I have used this formula here as well. Same formula. That is the formula for your first order reaction. We are using that. So here it is y is equals to mx plus c. So after comparing, this is y, this is x. So we can say slope is equals to k by 2.303 and intercept is 0 here. So that's why it is starting from origin and the slope is inclining upwards because it is positive in nature, right? Next is, in terms of natural log, we have two graphs, right? This graph is between ln of A naught by AT and T. So if you see this, this is A naught by AT. The formula you should remember, right? AT is equals to KT. If you convert this into log of base 10, then this will be divided by 2.303. That's why we had this formula here, right? But if you have natural log, it will be simply like this. Now, if you compare this with y, this is y is equals to mx plus c, then can you see this is y and this is x. From that, slope is coming out to be positive of k and intercept is 0. That's why it is, because intercept is 0, that's why it is starting from origin and slope is positive, that is why it is upwards here. Right? Now, next is this one. We had the same thing. I am going to equate this. If I equate this, we know that ln of A naught is equals to ln of AT is equals to KT. So I want to draw a graph between ln of AT and T. So what I'll do, I'll mark it here. This is ln of AT. This is ln of A naught minus KT. So instead of writing it here, I can also write it here. ln of AT. It's just a mathematical things that we are doing, right? So this is y is equals to m. You can't draw the m here, right? Let's draw it here. You can write it like this. Minus of kt plus ln of A naught, so that you're able to understand this more clearly. This will be y is equals to mx plus c. Now, this is y, this is x. So slope is going to be minus of k and intercept is going to be ln of A. That's why this is not starting from origin, because there is some intercept. Intercept is the line that is touching the y-axis. When where this line is touching y-axis, that is this point. This point is ln of A naught. And slope is minus of k, that you can see here. Okay, everyone. Next two graphs are also very, very, very important. This now, you must have seen that ln of, I'll just show you here only. Okay? Otherwise, it will become hodgepodge. We know that ln of, if you see this here, I have already drawn this here. log of A naught minus log of AT is equals to KT by 2.303. Or I have also written it like this. Log of AT minus log of A naught is equals to minus KT by 2.33. If you compare this with, this is Y equals to, I'll just write it there only, right? If you compare this here, this is log of A naught minus log of AT. You can also write it as log of AT minus log of A naught. If AT is the first one, then this will be minus of KT by 2.303. That is the formula. From formula, we know this thing, right? Now, this is Y equals to, if you also write it in the same way, if you put it here, this log, if you shift it here, this will be equals to minus of K 2.303 T. This is log of A naught. When you compare this with a straight line equation, that is Y equals to mx plus c, right? This is m, this is x, this is c. So when you compare this, this is y, this is x. So slope is nothing but it is minus k by 2.303 and intercept is nothing but it is log base 10 of A naught. And you know, based on this, they ask you the questions. They will give you some value of slope. Find the rate constant. If slope is given to be, let's say 3.1, then 3.1 is equals to minus of k by 2.303. That's how you can calculate the value of rate constant, right? So these kind of questions they ask you in the exam, right? They will give you the slope. They can also give you the theta value here. And also remember that slope is always equals to tan theta. You know, sometimes very smartly they will give you the value of tan theta. Tan theta is this. That means they have given you slope here. If slope they have given, you can, in this slope is this. In this slope is minus of k. In this slope is k. In this slope is k. In this slope is k by 2.303. So whatever is the graph, depending upon that, you will compare the value of slope. Okay, students? Clear everybody? Any problem till here? Because next 3 graphs are going to be different as compared to the graphs that we have done till now. Okay? Yes. Yes, everybody. Next 3 graphs are going to be different here. Let's see how ma'am, they are going to be different. See this thing here, right? Simple thing is, they are asking you to calculate the graph like this. See, exponential form. So this is AT, this is T. So we know the formula, ln is equals to A naught by AT is equals to KT. Right? If you reverse this, it will become ln of A naught by AT is equals to KT. So we can say, you reverse it, it will become ln of AT by A naught is equals to minus of KT. You have reversed this also, this sign also will change. Now, natural log and exponential are opposite of each other. So when you take exponential on both sides, exponential here as well. So what will happen? This will be e raised power minus kt. Here exponential and log will cancel each other and the answer will be AT by A naught, or I can also write it here. Answer will be AT by A naught equals to e raised power minus kt. Or you can also write it as AT equals to A naught by e raised power minus kt. This is what is written here, right? Now you know this particular equation. Now let me know in the chat box if there is any problem in understanding how I equated this. If there is, because you guys, I know that these things are difficult for you. Natural log and exponentials are opposite of each other, right? They cancel each other, right? So when I say AT is equals to A naught e raised power minus of KT, you have to also understand what I am saying here. Right, everybody? Now, I am saying AT is equals to A naught e raised to power minus of KT, then this is why this is equals to X is T. Now, very carefully, in exponential, growth is either like this or growth is like this. Either it will increase or it will decrease, something like exponential growth will be there, right? As the time is increasing, sudden decrease will be there or sudden increase will be there. Now the question is, ma'am, why it is decreasing? Why it is not increasing? See this very carefully here. Students, this is the equation that we know. See, tell me one thing. As time will increase, the value of minus of KT. So if 5 is more, minus 5, see, tell me one thing. 5 is more, minus 5 is less. 7 is more, minus 7 is less. So if value of this is increasing, then this value is decreasing. If I am going from 5 to 7, then minus 5 to minus 7, it is decreasing, right? So if I say time is increasing, then minus of KT will decrease. So can I say this here? Time increases, then minus of KT is going to decrease, right? Now, if this value decreases, then if you see this time is increasing, ma'am, minus of KT will increase. Then if you talk about exponential here, exponential will be e raised to power minus of KT, right? So this exponential value is also going to decrease here. See, if this value, this power is decreasing, exponential, we know that e raised to power 0 is less as compared to e raised to power 1 is less than as compared to e raised to power 2. As the value of exponential is increasing, the power is increasing, exponential will also increase. So here minus of KT is decreasing, so e raised to power minus KT will also decrease. That is the reason this is a decreasing graph here, right? Okay. Same with these two things. Here also, you need to be like fully attentive, right? What I'll do now, I'll just, because I would love to see if you're doing this in like full detail, right? Okay. So let's see this here. Let's see this here. So here you have to draw a graph between X and T. We know that, students, A T is equals to A naught e raised to power minus of KT. Right? Now, what is the value of X? Can you tell me what is the value of X? We know that X is nothing, that is A naught minus AT, or you can say X is nothing, ma'am, but it is AT. No. You can say AT is equals to A naught minus X. So X will be equals to A naught minus AT. That is the value of X, the amount that is left behind, right? So for this value of X, I need to know what is the difference in A naught minus AT. So I need to know that. So for that, what I'll do here, right? This is AT. I need to subtract A naught here. So what if I do the same thing in both the cases? This is A naught minus AT. This is also A naught minus this. So I subtracted here also, I put A naught minus. Here also I put the same thing. That means I subtracted this value also from A naught, this value also from A naught. Right? So this is why I have what I have put here. Now students, can you see one thing? This is nothing but this is X. X is equals to A naught is common here. This is 1 minus e raised to power minus T, KT. Yes, everybody, let me know if this is clear to you or not. If this thing, how I equated this particular equation, if that is clear to you, you can let me know in the chat box. Right? Okay? Is this equation clear? Now, if I start solving this, right, what I'll do? We know that as time increases, minus of KT decreases. As minus of KT decreases, e raised to power minus KT also decreases. Now you are subtracting from 1, you are subtracting 5. From 1, you are subtracting 7. This is equals to like minus 4. No, let's not subtract a bigger value, right? Let's say from 10, you are subtracting 7. From 10, you are subtracting 5. So this is nothing but 5. This is nothing but this is 3. So as this value increases, this value decreases. This value, as this value is decreasing, this value is increasing. Can you see that? That means, can I just simply write here? Can I just simply write here that if e raised to power minus kt is less, then 1 minus e raised to power minus kt will be more. If the subtraction unit is decreasing, then the overall answer will increase here. That's why in this case, this is exponentially increasing. Okay, everybody, clear why this is exponentially increasing? Yes, students, is that clear why this is exponentially increasing? Why this is exponentially increasing? Now, I'll talk about the last graph here, right? That is this one, right? For that also we have to, draw this, like we have to firstly know that how this is equated now, right? Now, see, students, we know that what is the value of alpha? Tell me, what is the value of alpha? Alpha is equals to number of initial moles. Initial moles are, number of moles dissociated, that is X, and initial moles are A naught. This formula we already know that X is equals to A naught 1 minus e raised to power minus kt. So I'll just put it here. X is equals to A naught 1 minus e raised to power kt. Now, if you do this here, this will be X by A naught is equals to 1 minus e raised to power minus kt. This is nothing but this is alpha. So, can I say alpha is equals to 1 minus e raised to power minus kt? Now, this is the equation that you have, right? This is the equation that you have, right, everybody? Now, next question will be, ma'am, time is increasing, minus kt will decrease. If minus kt decreases, e raised to power minus kt will also decrease. Then 1 minus e raised to power minus kt will increase. That's why as time is increasing, the value of alpha is increasing exponentially. Okay? Write it. Okay, everybody. Right? Clear? Graphs are clear. See, it's not like this is the graph, guys. This is how it is. This is the graph, guys. I have given you proper explanation why it is so. From just one equation of first order reaction, we have drawn all these graphs. Okay? Right? Yes. Perfect. Perfect. Now let us solve some questions of first order reaction. But before that, spam this chat box with green heart so that I can also know that you are awake, you are there, you want to learn something. There is still energy left within you. Yes, everybody. Yes, everyone. Perfect. Perfect. Okay. Yes. Now what we have? Integrated rate law equation for first order gas phase reaction is given by Pi is equals to initial pressure, Pt is equals to total pressure, and this is the full-fledged example here, right? Now let's understand that. See, this is what they have given you, right? Instead of doing it like this, I'll just simply solve it for you, right? Okay. See. Initially, we are not calculating in terms of pressure. We are calculating in terms of, we are not calculating in terms of concentration. We are calculating in terms of pressure. So, initial pressure is, let's say, Pi. It is 0. It is 0. It will be Pi minus X. Here X amount will be formed. Here X amount will be formed. Right? Now let us see what they are saying. They are saying total pressure at time t is Pt. Okay. Total pressure at time t is Pt. That means this is the total pressure at time t. So I can say that Pt equals to, that is the total pressure. Students, this is the total pressure at time t. This is not the final pressure of A. Right? This is total pressure is equals to Pi minus x plus x plus x, that is going to be Pt is equals to Pi minus x. This is the first equation. Next is they are saying first order gas phase reaction is given by initial is this, total is this. Okay. First order gas phase reaction. Okay. So if you see this here, what is the value of x? X is equals to Pi minus Pt, P total, right? Now, what is the final value? What is P small t? See, P capital T is total pressure. P small t is final pressure of reactant. Okay, so what is the final pressure of reactant? Understood now? They have given that at time t, this is time is equals to 0, this is time is equals to t. They have given at time t total pressure is P capital T. Right? I have taken it as P capital T. So here also I'll put it as, chalo yaar, here they have taken it as P small t, then what to do? What should I do? Should I just reverse it? Wait a minute. Because I can't erase. You will say, ma'am, why you are not erasing here, right? So this is P small t is equals to Pi, this is the total pressure, minus x plus x plus x. Here the denotation is P small t is total pressure. Okay. Now, if I solve it here, this will cancel out. It will be, what is the value of x? It will be Pt is equals to Pi plus x, right? What is the value of x? X will be Pt minus of Pi, right? That is the value of x. So when you solve this equation here, how do you solve this? Simple, right? They are asking you what is the value of k here. So k is equals to 2.303 by t log of initial is Pi, final is Pi minus x. X is nothing but Pt. This is minus plus, that is Pi. So it will become 2.303 by t log of Pi divided by 2 of Pi minus Pt. So that is going to be the value of k, 2 Pi minus Pt, 2 Pi minus Pt. So answer will be A is the correct answer here. Wait a minute, this is 2 Pi or T? This is also coming out to 2 Pi minus Pt. This, I think this is 2 Pt minus Pi. Hai? This is Pi minus Pt. So answer will be C is the correct answer. Okay. So answer is going to be C is the correct answer here. Very good, Adina, Ruth, Manu, Alina. Very good. Very good. Awesome. Awesome. So that is done. We have completed it. Wait a minute. It should be Pi minus Pt, right? I think I have just not able to understand which is Pi and which is Pt. So I don't know if this is Pi, there is some blurriness. Achha. This is, I think, then if they are saying that A is the correct answer, then this should be Pi and this should be Pt. Then this should be Pt and this should be Pi. Okay, because I think A and C both are the same options only. There should be some difference here. Only then we can say which is the correct. So A will be the correct answer here. If this is Pi and Pt, that you can tell, na? This is the answer. So whatever option matches this answer, that is the correct answer. Okay. Chal. Now, this we have done already, right? This we have done already, right? Now, let's see next question here of NEET 2025 based on this particular reaction, this particular concept. If the rate constant of a reaction, guys, can you see what is given to you here? Rate constant means K is given to be 0.03 per second. See, whenever rate constant is given in per second, see, general formula of rate constant is units are mole per liter 1 minus n per second. For n is equals to 1, units are per second. That means definitely it is a first order reaction. From this we can be sure that this is a first order reaction, ma'am. Yes, so it is a first order reaction. We can say first order reaction from the units. From this unit is defining that it is a first order reaction. Okay. It's not like ma'am is teaching first order reaction, under that this is the question, so it will be a first order reaction. You have to ask why it is a first order reaction. Nowhere it is given that it is a first order reaction. Because of this unit here, it is a first order reaction. How much time does it take for this concentration of the reactant to get reduced to this? That means this is the final concentration. This is the initial concentration. Such a simple question, right? So simple, yaar. What's the big deal in this? Very simple. Let's apply this formula. How much time, na? How much time? So time is equals to 2.303 divided by 2.303 divided by K. Log of initial concentration is 7.2, final concentration is 0.9, right? You can easily, such a simple question here. K is nothing. What is K is given to be 0.03. Just put in the values here, right? Simple question. Even the calculations are also very simple, right? So this is going to be 0.03 divided by 0.03, right? This is log, this is 72 by 9, which is such a simple calculation, right? Now you have to solve it, and I know easily you can solve it. Such a simple calculation is there, right? Such a simple, easily 9 and 72 are cancelling each other, right? This will also be easily cancelled, and you can easily calculate the value. Even log of 2 values also they have given you what is the value of log of 2, right? So after solving, you can get the value easily. This is 2 cube, right? That will be 3 into log a. See, one thing you should know, log of 2 cube, how you will solve, right? That will be 3 into log of 2. So it will be 3 into 0.301, right? This is what you will put here, and you will get the answer in seconds. How do you get the answer in seconds? Because this was given in per second, so answer will be in seconds. If this was given in per minute, then the answer would be in minute. If this was given in per hour, then the answer would be in hours. Okay? Right? Very good. 69.3. Very good, Adina. That is the correct answer. Next is, they have given a question based on NEET 2025. See, very simple questions they have asked in NEET 2025 in chemical kinetics. Can you see, was it a tough one, right? So, first order, zero order, very important these topics are, right? So, if a half-life period, they are saying if a half-life period for a first order reaction is 1 minute, half-life period for a first order reaction is 1 minute, which is also 0.693 divided by K is equals to 1. So K is equals to 0.693 per minute, right? Now, they are saying, now students, it's a very important question based on the percentages, right? So let me just explain you. Whenever they have given you something like percentages, I need a blank page for that, right? Where I can get a blank page. No blank pages there, beta. No blank pages there. Let me see. Yes, we have one blank page, right? I'll just copy paste it here, right? See, very important thing I'm going to tell you here. Whenever initial and final concentrations are not given, right? You know what they will do? Two things they can do here, right? Two things they can do here. One is they can give you it in fraction. So first you have write percentage. One is they can give you in percentage. Other is they can give you it in fraction. So whenever it is given that 90% is consumed, 99% is consumed, you will always take A naught value. You will take the value of A naught as 100, right? Let's say they are saying that 90% is consumed. That means 80 is equals to 100 minus 90. Let's say they are saying that 90% is left behind. Then you will see 80 is equals to 90. Okay, according to that, it will change, right? If they have given it in fraction, then students, the initial value, initial concentration, you will take it as 1. Let's say they are saying it is 1 by 4th is 1 by 4th amount of the reactant is consumed. You will say 80 is equals to 1 minus 1 by 4th amount that is consumed. Or if they say 3 by 4th is left behind, so 80 will be 3 by 4. Right? So according to that, you will answer. Now this is very important that for percentage take initial as 100, for fraction take it as 1. Now here they have given it in percentage. Time required for this much completion of reaction. So A naught you will take it as 100, right? 80 will be how much completion is there? 100 minus 99.9% is completed already. Now, one thing is you should also know the direct relation here, right? Okay, that also I'll teach you. Okay, I'm just here. I'm not teaching you the direct. I'll teach you direct relation after this question. Okay, so if you see this here directly, what you will do? They are asking you T is equals to 2.303. If you don't know the direct formula, then I am telling what you have to do, right? So this will be equals to 2.303, right? This is the divided by K log of initial A naught divided by 80. A naught value you know, 80 value you know, K value you know, put it and solve it, right? Okay. Now, I'll also show you one more thing. This you can easily calculate, put it, solve it, you will get your answer. This is given in a more complicated form, but we will not get into that much complication. When you solve it, your answer will be 10 minutes, right? Because this was given in minutes, so answer will also be in minutes, right? Now, see this one thing here. Before going towards this question here, I also want to teach you something regarding first and second order reaction before going to the graphs. Okay, yes. So let's understand this very, very, very important concept here, right? Let's understand this very, 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 very important concept here that is repeated I don't know how many times, right? Okay. Yes, everyone. Wait a minute. Okay. Yes. Yes, everybody. Thank you. Thank you. I completed my NEET with your support. Thank you, Raj. Okay. So let's see this thing here, students. It's a very, very, very important thing. That is, let's say I am talking about zero order and first order reaction. Okay. So if I am talking about, let's say, zero order reaction. Okay. for zero order reaction. For a zero order reaction, always remember that if, let's say, for initial to A by 2, the time is t half, then A by 2 to 0, it will be 2 into t half. That means total time of completion for a zero order reaction is 2 into t half. Let's say I am saying t half for a zero order reaction is 20 minutes. Then after 40 minutes, that reaction will be fully completed. That is for zero order reaction. Okay? Yes? If I say t half is 10 minutes, then after 20 minutes, reaction will be completely completed, right? That is for zero order reaction. But if I talk differently here, if I say let's talk about first order reaction, guys. Let's talk about first order reaction. First order reaction. Question is it the same thing now or not? Right? Navi, it's definitely live, yeah, right? Okay, so first order reaction, let's talk about this thing, okay? So, in this, what happens, this is a very important thing, guys. It's very, very important. Please focus here, right? So, if let's say this is A naught, this is decreasing to A naught by 2, and the time required is T half. Now, after one more T half, will it be completed or not? That is the main question, right? Will it be completed or not? That is the main question. So after T half, after one more T half, right, what will happen? It should not be 2 into T half, it should be T half only. Wait a minute. Here it should be T half. Just wrote it in a wrong manner. This will be T half. From initial, it will be 2 into T half. Completion is from 0, now this will be 2 into T half. Okay. Now, for a zero order reaction, after one T half, it is 50% completed. After one more T half, it is fully completed. That is for zero order reaction. But for first order reaction, after one T half, it is A naught by 2, that is true. After one more T half, it will be half of this concentration, that is A naught by 4. After one more T half, it will be half of this, that is A naught by 8. After one more T half, it will be A naught by 16. After one more T half, it will be A naught by 32. After one more T half, if you are saying, ma'am, one more T half, ma'am, right? After one more T half, it will be A naught by 64, and it will go so on, right? This is for first order reaction. That's why it is said that for a first order reaction, it will never be completed. It will never proceed towards the completion. First order reaction will never proceed towards the completion. It is going on, right? So that's why the question for T 99.9% will be asked for first order reaction, not for zero order reaction, right? Okay. So here, very important thing, right? This we have done. So you can write it like in simple, you can write it here. AT is equals to A naught by 2 raised to power n. N is the number of T halves. N is the number of half-lives. See, if I want to compare this, if I want to put n is equals to 2, so AT is equals to A naught. After 2 half-lives, it will become 2 raised to power 2, that is A naught by 4. Yes, after 2 half-life, it is becoming A naught by 4, right? After 2 half-life, it is becoming A naught by 4. If I put, let's say, ma'am, I want to put n is equals to, after I want to calculate after 6 half-lives. So it will be 2 raised to power 6, right? So 1, 2, 3, 4, 5, 6. After 6 half-life, you have A0 by 64. 2 raised to power 6 is nothing but 64, right? Okay. Is that thing clear to everybody? Yes, everybody. Ma'am, I want Telegram notes, please. Notes will be provided on Telegram or your YouTube channel, in the comment section, in the description box, everywhere. Right? Okay? Yes. Now, this is done. Now, it's not completed yet. Yeah, there's some other things also left, right? So, now you have this thing here. Students, let's see it as more detailed, right? This is A0 by A0, 50% is completed. Can I say 50% is completed? In this case, how much amount is completed? A0 by 4, how much amount is completed? 1 by 4th is left behind. That means this is 50%, this is half of 50%. I'll just also write it here, right? This is half of 50%. The time will also get half. This is 50% is completed. After this, half of this is completed. That means 25%. 25% is more consumed. After this, half of this is consumed. That means 12.5% is consumed here. In this case, how much amount is consumed further? This is 6.25 is consumed. Here, half of this, that means 3.125 is consumed, and so on. What is the half of 3.125? I think it will be something 1.5 something, right? Let me just see that. What is the half of? Let me just see that. What is the half of 1.325? Chalo. Firstly, let us see what is the 6.25 divided by 2 is 3.125 divided by 2, it is 1.56, right? 1.56. Now you will be like, ma'am, what you are doing? See, I am just writing. I know that here 50% of this is completed. Here 25% of this is completed, right? More 25%. That means half of this, what we have here, half of this is completed. That means here we had 50%. Half of this means if I start from the initial value, can I say total 75% is completed here? From initial value, can I say here total 75 plus this 87.5 is completed here? Right? I think it will be 87.5 only. By practice, yaar, what to do then? 50 plus, I think it is 25 plus 12.5. Yes, it is 87. Now, after that, you add 6.25. That is from this point to this point. How much amount is completed? It is 93.75. From this point to this point, I know it's kind of messy. You add more of 3.125. That is 96.875 is completed. From this point to this point, how much amount? Add 1.56 here. 98.435 is completed. And it will go so on and on and on and on and on. Okay? Yes, okay, everybody? Yes, everyone, right? Now, I'll just copy paste this thing here. Now, can you tell me the answer of this one, right? Now, I will generate now. This you should know how to do this. Otherwise, I am also going to tell you some formulas here, right? So, always remember these formulas, right? Because they will be very, very beneficial. Here, I'm not drawing everything here. I'm just writing simple formulas here. From doing all of this, we can say that T is 75%. That means if 75% of this you want to consume, you need 2 half-lives. So T 75% is 2 into T half, right? Time required to complete 87.5 is nothing but 3 T half. 87.5 is equals to 3 T half. Okay. Then time required to complete 93.75. Usually 93.75 they will not ask you, I'm just writing it here. Now you have to tell me time required to complete 99.9 is what percentage of T half? Yes, everybody. Time required to complete 99.9 is what percentage here? Yes, everybody. Yes, everybody. This is 10 T half. And this is very, very important. Very, very, very important. Right? This is very important. Mostly this is very important. This is very important. Right? Okay? Any problem here, students? Any problem here? Right? Okay. So that was about the important concept that I was telling you, right? Now we are left with easy things only, right? Most of the things we have done. Now we'll do some questions, then no derivation, nothing. I'll just going to tell you some formulas because the most important parts we have already completed. Now I'll give you some parts that usually we have not focused till now, but now we will focus because level has increased, so your preparation also has to be good, right? So firstly, let us see this. This is a valid for first order reaction. This is valid for first order reaction. See, one thing is T half is equals to K is equals to 0.693 divided by K. So it is not at all dependent on A naught. So it is definitely valid on first order. It is valid for first order reaction. That is true. This is valid for first order reaction. See, log is equals to, this is final concentration by initial. If you have final concentration by initial concentration, it will be minus of K by 2.303 T. This should be negative. This should be minus of K by 2.303. You can check it out from the formula as well. That means this is a wrong statement. So we can say statement 1 is true, B is false. Right? So answer will be B is the correct answer here. Right? Okay, next is this I have already told you, right? Next is, let's see this. Initial concentration of N2O5 in the first order reaction is given to you. Yes, everyone, initial concentration of a first order reaction is given to you. This is the first order reaction, it is this. The concentration of N2O5 for 60 minutes was this. Calculate the rate constant for the reaction. Okay. Initial concentration is there. The concentration after 60 minutes was this. That means this is the initial concentration. This is A naught. The concentration of N2O5 after 60 minutes, it will be 80. Calculate the rate constant. Simple, it is K is equals to 2.303. Divided by time is 60 minutes, right? And here it will be log of initial concentration is 1.24 into 10 raised to power minus 2. This is 0.20 into 10 raised to power minus 2. Solve it, calculate it, and you will get your answer of rate constant here, right? Okay, just by putting the value in the formula, that is, what is the formula? Formula is log is equals to 2.303 by T log of initial concentration by final concentration. The formula only I have put it here and you will get your answer here. Right? Okay. Done. Next is rate constant for a first order reaction is this. How much time it will take to reduce to initial concentration reactant is 1 by 16. Now it is given in fraction. Same thing, same formula. That's why it is very easy topic, right? So rate constant they are asking you is this. This is rate constant. Time required you have to see it is 2.303 divided by K log of A naught by 80. So T is equals to 2.303. Now K is given in seconds, so time will also be in seconds. So this is seconds. Initial concentration, you have to assume. So I told you, whenever things are given in fraction, take initial concentration as 1. Final will be how much time will it take to reduce initial concentration to 1 by 16th of its value. So if initial concentration is 1, final will be 1 by 16. So simple answer you can solve. So this is 1 by 16 is nothing but 16. So you can put that is nothing but 4 square, right? That is nothing but, you can say, 4 raised to power 4. 16 is nothing but 2 raised to power 4, no? 2 into 2, 4, 2 into 2, 4, 4 into 4, 16, right? So 2 raised to power 4 I have directly written. 2.303 by, chalo, I'll write here 16 only, then you will be like, ma'am, what is this direct you are doing? Log of 2 raised to power 4. Now this also I can write it as 2.303 by 60. This is 4 multiplied by log of 2. Log of 2 is nothing but it is 0.301. Solving this, you will get your answer for K. Okay? Very good, Adina. Very good, Mano. You have already solved it. Awesome, awesome, awesome. Very good. Very good. Right? So by this, you can easily solve this value here. Right? Okay, everybody. Okay, everybody. Yes. Now, let's talk about what is pseudo first order reaction. See, pseudo first order reaction. Pseudo means, what do you mean by pseudo? What do you mean by pseudo? Pseudo is false. Something that is not true. So, any reaction which kinetics which is studied by decreased order are known as pseudo first order reaction. That means in reality, right, when we see this reaction, what we are thinking that it is a first order reaction, right? But in reality, it is not a first order reaction. That's why it is called pseudo. It is a false first order reaction. Because whenever any particular reactant is in excess, then we get a pseudo first order reaction. Or you have, it involves any catalyst. Then also, if the catalyst is involved there in the rate law expression, then also it is a pseudo first order reaction. Okay? So two ways, one is catalyst, other is if any of the reactant is in excess. Right? Okay? Reaction of A plus B is given by the equation this. B is taken in large excess. What would be the order of the reaction? What would be the order of the reaction, everybody? Now they have given you B is taken in large excess. So that means it is going to be a pseudo first order reaction. If B is in large excess, then rate becomes independent of B and will depend only on A. Therefore, the order of the reaction with respect to A is 1. That is a pseudo first order reaction. In reality, it is not a first order reaction. But because one of the reactant is in excess, that's why it is behaving as a first order reaction. If that particular reactant is not in excess, then it will not behave as a first order reaction. Okay? Yes, everyone? Now, let's see this here. The rate law of this reaction is given by this thing. A is taken in large excess. The order of the reaction will be again the same thing. If you take this in large excess, then it becomes independent of A and it is going to be a pseudo first order reaction. So whenever any of the reactant is in excess, automatically that becomes your pseudo first order reaction. Okay, guys? Now we are going to do second order reaction here. Right? Second order reaction and then nth order reaction. So if you see second order reaction, derivation and all, very rarely, you don't need the derivation of this, right? Simply just remember one thing. 1 by AT is equals to KT is equals to 1 by A naught. 1 by AT, that is the final concentration, is equals to KT, rate constant into time, plus 1 by A naught. A naught is the initial concentration, that's it, right? This is all what you have to remember. right? Okay. Now, let's see this question here. NEET 2018 question, that is the correct difference between first and second order reaction is what? What is the difference between first order and second order reaction? So first is rate of first order reaction does not depend upon reactant concentrations. Rate of second order reaction does depend on this. They are asking you which of the following is correct. So next is the half-life of first order reaction does not depend on A0. First order reaction, yes, it is true. Half-life of second order reaction does depend. See, for half-life, no, when I'll talk about nth order, I'll also tell you a general formula of half-life based on the nth order. So half-life is directly proportional to initial concentration raised to power 1 minus n. This is a very, very, very important thing that is going to solve so many questions, right? So if you see n is equals to 1, then it will be 1 minus 1, that is a0 raised to power 0. This will become a0 raised to power 0, that is nothing but 1. So that's why it is independent for first order reaction. If you put n is equals to, so it will be a0 is equals to 1 minus 2, it will be a0 raised to power minus 1. That means it is inversely proportional to a0. So in the second order reaction, it is inversely proportional. That means it definitely depends. So that is correct. First order reaction can be catalyzed. There is no said the rate of first order reaction does depend on reactant concentration. Does not depend. So out of this, B is the correct statement here. So answer is B is the correct answer here. Right? Very good. B is the correct answer here. Last is your nth order reactions, right? Any general order. So I would really advise you, instead of learning second order reaction, learn nth order reaction formulas. Why? You never know, they give you some difficult questions in the exam, you will be able to solve it. And today I'll also give you one example of that such reaction. One of the JEE means previous year question, till now they have not asked that question in NEET, right? Chances are they can ask you. Chances are they can ask you, right? So for nth order reaction, let's see the general formulas. General formula is this, where C is equals to final concentration, and C0 is your initial concentration, right? And if you put the value 2 here, you will get the formula of second order reaction. Okay. So here it is. K is equals to 1 by T n minus 1, and this is not applicable for first order reaction, right? Because in first order reaction, you have log. So that's why this is not directly applicable for first order reaction. You can't generate the formula of first order reaction from this, right? So you can generate zero order, first order, you can generate that, right? So that's why it is K is equals to 1 by T n minus 1, where n is the order of reaction, right? Bracket 1 by C raised to power n minus 1, 1 by C0 raised to power n minus 1. Okay? Right, everybody? Yes. If you want me to write it, ma'am, we love, ma'am, how you write it. Then how I would write it is different, because I always write it in the form of A0 and AT. So how I would write it is 1 by K is equals to, this is the 1 by T n minus 1 bracket 1 by AT. This is raised to power n minus 1 by 1 by A0 raised to power n minus 1. Right? This is how I will write. You can also see this particular reaction here. That's totally your choice. How you want to remember this particular thing here. Right? It's totally your choice how you want to remember this. Okay? Just remember that this is defining final concentration. This is defining initial concentration. That's it. Okay, you can remember this. You can remember this. Oops. I write it there only. So I'll write it here, right? This is a better way of writing. K is equals to 1 by T 1 n minus 1 1 by a t, 1 minus n minus 1, minus 1 by a naught, n minus 1. Right? And if you say, what is the ma'am formula of t half? Even if you remember just one thing, that t half is directly proportional to a raised to a naught raised to power 1 minus 1, even then it is like good, right? If you don't want to remember like full-fledged formula of t half, even if you remember just this formula, even then it is good only. That is not bad, even if you remember just this, the formula, right? But if you want to know the full-fledged formula, this is the formula, right? But I would not advise you to learn this, right? You just remember that t half is directly proportional to a naught raised to power 1 minus n. That's it. That is enough for you, right? Now, ma'am, how the questions are asked here based on this? Let's see. One is a simple question that till now they are asking, or NEET, these kind of questions, till now they also ask, right? That is the half-life of sample of two sample are this and this. This is sample number A has half-life 0.1. Sample number B has half-life 0.4. Their respective concentration are, concentration of A naught of A is 200. Initial concentration of B is 50. Now we know that what is the order of this reaction? We know that T half is directly proportional to A naught raised to power 1 minus n. So can I just write it in the same way? Can I just write it in the same way like this? Can I write it in the same way like this? That T half of A divided by T half of B is equals to A naught of A divided by A naught of B raised to power 1 minus n. Okay. So T half of A is nothing but it is 0.1. T half of B is nothing but 0.4. A naught of A is nothing but 200. This is nothing but 50 raised to power 1 minus n. So if you compare this, this will be 1 by 4 and this will be 4, right? So this is 1 minus n. So what should I make the value of this n so that it turns out to be 1 by 4? If it can make 4 inverse here. 4 inverse is possible if this whole value is equals to minus 1, right? That means, can I say that 1 minus n is equals to minus 1? So n will be equals to 2. So that means it is a second order reaction. Very good, Manu. It is a second order reaction here. So we can say it is a second order reaction. That is done and done, right? Answer will be it's a second order reaction. Okay. Last question of today. J means 2025 question it is. So everybody, it can as it is be repeated in your NEET exam, right? Okay. Okay. Ma'am, how you manage chemistry during high school? See, nobody is an expert, right? Everybody practices. Even when I was of your age, I was not an expert in chemistry or physics or mathematics. No, right? I used to like chemistry. I used to spend time solving questions of chemistry, right? But definitely, I used to make mistakes, right? Even now, but practice, practice, practice. Then I used to get scared of difficult questions, just like you are getting scared, right? It's not like, see, it's been years. It's been like, I have passed my 12th class in 2014. It's been years, right? Years of practice. So I would advise you, do as much as practice as possible, because the questions that I used to get scared are so easy. This is what I feel now, right? And you will also feel the same. More practice will make you perfect, right? And even then, last part is nobody is perfect, guys. Nobody is perfect, right? Just try to understand the concept as much as possible, right? Okay. So everybody ready to solve this question? Ready to solve this question, everyone? Right? Ready to solve this question? Very interesting one. How many of you are getting scared of just looking at this question? Oh my God, this seems a very tough question. Let's leave this. In reality, this is not a difficult one, right? I'll show you how. They are saying they have given a table. This is a table. In this, they are saying if T half is 200, then A naught is this. T half is 100, then A naught is this, right? Now I will solve this equation one by one. I need to keep one extra page here. Is there any extra page, guys, for your Diksha ma'am? Ma'am needs one extra page, right? So I'll just copy paste this here and here, right? There I'll delete this. Wait a minute. Chalo. It's not getting deleted, no worries, right? So I'll solve it within this box only, right? Yes. Okay. Now let's solve this question, okay? Now they are saying for a given reaction, T half is related to A naught as given in the table. This is how T half is related to A naught. Which of the following option is true? See, in JEE, they have asked it in a multiple answer form. But in NEET, you don't have multiple answers. So what they can do is, after giving you this first statement, second statement, third and fourth, they can give you option A is 1, 2, 3 is correct. Option B is 1 is correct. Option C is 4th is correct. That's how they can, mold this question in terms of NEET, right? So that's why I have picked up this question for you. So first is order of the reaction is half. Okay, how do you define the order of the reaction? You have two half-lives, you have two A naught. So let's solve it, right? Let's solve the order of the reaction here. Simple way we will solve the order of the reaction here. We know that T half equals to directly proportional to A naught raised to power 1 minus n, right? So when your T half for first case, we can say T half of second case is equals to A naught of first case divided by A naught of second case raised to power 1 minus n. So if you see this here, this is the same thing that I have done before. Same question. Have you seen? Same question we have done. This is 20, 50, 0.1, 0.4. Same thing we will do here, right? So it is T half is coming out to be 200. It is 200, right? When the value of A naught is 0.1. So I'll just put it as 0.100. Here, the value of T half is coming out to be 100 when it is 0.025. Here it is 1 minus n. Now see this, it will be cancelled, it will be 2, right? So you will write 2 here, right? And here it is 25, 4. So it will be 4 raised to power 1 minus n. See, if you have to make 4 raised to power 1 minus n as 2, then this should be under root of 4. That means it has to be 4 half is equals to 2. That means 1 minus n is equals to half. That means n will be equals to 1 minus half. That is n is equals to half. That means the order of this reaction is coming out to be half, right? So I did the same thing here, right? So how can I make this 4 raised to power 1 minus n? 2. If there is under root here, that is possible if 1 minus n is equals to half. So that's what I equated here and I got the answer that yes, A is definitely the correct statement. This is definitely the correct statement, but this is a multiple answer, right? So A is the correct. I am not saying others are wrong, right? Let's see the next one. See, in NEET, they will not ask you multiple answer. But what I told you is they can ask you how many statements are correct here like that. Okay, so let's see if the second statement is correct or not. If A naught is 1, then T half is under root of this. For this, what we will do? This is statement 2. Same thing we are going to do here, right? Wait a minute. Same thing we are going to do, guys, here, right? What I'm going to do here, this is T half, right? Now they are saying that T half is equals to, now they are saying that if A naught is 1, for some value A naught is 1, then T half will be under root 200 this. Is it correct or not? Let's see. Pick out any value this or this from here. I'm comparing this set and this set here. Let's see if it is getting true or not. See, I know that if it is n minus 1, so it is already half, so it will be half. So can I say T half of first case, that is 200, divided by T half of unknown is equals to, for 200 it is coming out to be 0.1, so I'll put it 0.1 and 0.1, and for this one it is 1. Okay, so I'll put it 1. This is half. So that means T half will be 200 divided by, this is nothing but 10 now, so I can also write it as 10. Okay, so that is 10. Okay, that is correct only. Hai T half is nothing but under root 200, 200 under root of 10. Is this what they had given you in the equation? Yes. If A naught is 1, then T half should be this. Yes, it is also the correct statement. So A and B both are the correct statement. Can we see the third statement here? Let's see that. Okay, let's see the third statement now. Let's see the third statement, that is, third statement is, order of the reaction changes to 1 if the concentration of reactant changes to this to this. See, tell me one thing. Is order dependent on concentration? No. Order is an experimental quantity. How come they are saying that order of the reaction will change? This is definitely wrong. Last is T half is 800 minutes if A naught is 1.6. Same way we will calculate this. See, T half is directly proportional to A naught raised to power half. So for one condition it is 200, and here they are saying T half you have to calculate, so I'll put T half here. For 200 it is 0.1, and for this T half that I want to calculate is 1.6. So it is 1.6. This will cancel, this will be under root 2. So this will be nothing but 1 by 4, because under root of 16 is nothing but 4 now. So what is this? This is 1 by 16 under root, right? So it is 200. This is T half. So T half will be 200 multiplied by under root of 16, that is nothing but 4. So T half is going to be 800 minutes. So that means this is also the correct statement. So based on nth order reaction, they have asked you A, B, C. You know, in one of the option it will be 1, 2 and 4th is the correct statement. So that will be your correct answer if they ask the same kind of question in NEET. Okay. Yes, everybody. Clear? Right. So full-fledged we have done, like full-fledged, whatever was needed, right? We have done it here, right? Whatever was needed, we have done it here. So statement will be A, B and D is the correct statement in this case. Right, this is a very important question of JEE Means 2025. Just wait a minute. Just this year they have asked this, right? So easily this can be repeated. So that's why I have taken it here. Mark my words, it is an important question, right? Okay. So now guys, we have done this and this is your homework question, and I want you guys to do the homework. If you're not doing the homework, you're completely wasting your time. You're wasting my time. Everything is being wasted if you're not doing your homework, right? So do your homework on time, right? I want to see your homework. A, B, C, D, whatever is the answer. Is it correct, incorrect, doesn't matter. What matters is, have you done your homework or not, right? Okay, so this is the first question that I want you to do. Take the screenshot of this first question here, right? I think so it is taken. Now, take the screenshot of this second question here. Take the screenshot here, guys, right? Let me see how many of you answer this, right? And this is our Vedantu NEET English channel where all the classes updates are there on the channel. And guys, you were asking for DPPs, right? So DPPs are here. You will see session in this. I'll also mention this here that this is your DPP. Click on here and you will get to this particular link, right, which is totally free of cost. You will get the DPP of your solution chapter that we have already completed, right? Questions are given. Firstly, you will see all the questions. Firstly, I would want you to solve all the 25 questions. Then all the answers are also given to you, right? Okay. Understood, no? If there is any problem in the DPPs while solving, you can always connect me on Instagram, on Telegram. You can always connect me there, right? Okay. And guys, very important thing is that our DNA batch is also going on, right? All these doubt sessions, ma'am, when you solve the questions, doubt are there, then we take doubt sessions, especially in DNA batch, right? So in DNA batch, we take live sessions, right? In that leaderboards, quizzes are being done so that you can, every single lecture will be asking yourself, what is my weakness? And to improve that weakness. Then in the DNA batch, there are leaderboards. You can actually see your competition, right? You are not in any illusion. You are not in actually delusion, I would say, right? Okay, it's not delulu is not sululu, beta. So delusion, you will not live there. You will get to know, okay, this is my weakness and I am not able to have rank 1 in my leaderboard. That's why I have to do better. So that is an eye-opening thing for you, so that right now you have time to improve yourself. That's why that will be beneficial, right? Then students, we have after every 15 days, we have mock test, right? This Sunday also students have their mock test, right? So whatever we have completed in last 2 weeks, we'll take the mock test after the next week and next other week. Like after 15 days, whatever is completed in that 15 days, mock test will be taken for that. We also provide you Tattva modules, right? If you want me to show you the Tattva modules, there are really amazing questions are there. Previous year questions are there. Practice questions. Like there are so many questions. If you're able to do those questions, trust me, you don't need anything else, right? Trust me on that, right? So previous year questions, best questions of your NEET and AFMC, AIMS, JIPMER, best collections of questions are there in the modules, right? Then students, apart from this, we also provide you test series for your practice. If you want to practice test series on your own pace, in your own time, then we provide you that as well. So all of this is there under just 4,999. And there are different course plan for this as well. If you're like, ma'am, I want these kind of quick revision cards as well, right? These kind of quick revision cards you also need. You can carry it on your pocket, right? Any day, right? If you need these kind of cards, then this is for 5,999, right? This full pack, this is just chemistry pack, okay? Similarly, physics and bio will be provided to you. Like you can see so many cards are there, right? So that is full syllabus of chemistry is between this, right? So then there is Prime plus QR cards plus AITS series, test series, home delivered. That means with the OMR sheet, everything will be delivered at your home at 6,999. So these are the different variants that you have for DNA batch. Okay, so that's it for today, students. I'll see you in the next class. Bye bye. Take care. Yes. Bye bye. Take care. See you all in the next class. And I would love to see your comments and your homework in the comment section. Till then, bye bye.